In the last lesson, we looked at different things that we could say are true if we knew that a quadrilateral was a parallelogram. Now we're going to do the exact opposite. We're going to say if we know certain things are true, what can we use to determine that a quadrilateral is a parallelogram? So if a quadrilateral has each pair of opposite sides parallel, by definition, it's a parallelogram. This is not the only way, though, we can determine if a quadrilateral is a parallelogram. So let's take a look at the other ways we can prove that a quadrilateral, so a shape with four sides, is a parallelogram. The first one is if both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. So last lesson we said that if it's a parallelogram, these opposite sides are going to be congruent. Now, the inverse is also true. If these sides are congruent, the quadrilateral is a parallelogram. So if AB equals DC and AD equals BC, then ABCD is a parallelogram. Next, we say if pairs of opposite angles are congruent, then our quadrilateral is also a parallelogram. So this is just the opposite of what we learned last time. If they're equal, then it's if the opposite angles are equal, then it's a parallelogram. The next one is looking at the diagonals. So if the diagonals bisect each other, meaning they break each other into two equal parts, then the quadrilateral is also a parallelogram. And then the last one here, if one pair of opposite sides are both parallel, so this symbol here, and congruent, we also can say that the quadrilateral is a parallelogram. Let's take a quick look at the proof if you want to know why this is true. So if we're given that Wx equals Zy, so we're given these two are congruent, and Wz equals Xy, so if our opposite sides are congruent, we want to prove that Wxyz is a parallelogram. So what we can do is we can draw an auxiliary line, so just a line we draw to prove a point. So if we draw this line from z to x, we know by our reflexive property that zx is going to be the same, and we've formed two different triangles here. Formed this triangle and this triangle. And because we have three equal sides to each other, we can say by side, side, side that those two triangles are congruent to each other. And what we know about corresponding parts when our triangles are congruent are that their corresponding parts are also going to be congruent. So WXZ, this angle here, is going to be congruent to YZX. And then also our WZX, so this angle here, is going to be equal to YXZ. Then we can say that WX is parallel to ZY, so this line up here is parallel to this one here, and WZ is parallel to XY, so this one is parallel to this one, by alternate interior angles converse theorem. So since our opposite sides are parallel, then by definition, we have a parallelogram. Let's look at a couple examples here. So the first one, we want to determine whether the quadrilateral is a parallelogram. All right. So first, we know that the opposite sides, we have a set of opposite sides that are equal, 14 and 14. Now let's see, because if we know that these two lines are parallel to each other, then that's enough information. Opposite sides are equal and parallel to each other to say that we have a parallelogram. So can we prove that FG and JH are parallel to each other? And the answer is yes. So if we have parallel lines, then we know our consecutive interior angles are going to add to 180. So let's test. Does 100 plus 80 equal 180? Yes. So by the converse of our consecutive interior angles theorem, we can say that FG and JH are parallel to each other. And so if we have FG and JH parallel and they're the same length, we can say that the FGHJ is a parallelogram. Yes, because of this. Let's look at one more. So if FK equals 3x minus 1, so I'm going to mark our figure here. So FK is 3x minus 1. KG is 4y plus 3. JK is 6y minus 2. And KH is 2x plus 3. So we want to find x and y so that the quadrilateral is a parallelogram. So if it's a parallelogram, we're going to have both of these lines are going to bisect each other. So our FK would be equal to KH, and JK is going to be equal to KG if this is in fact a parallelogram. So let's substitute in our equations for those. We have 3x minus 1 equals 2x plus 3. And then JK is 6y minus 2 equals 4y plus 3. Now we want to solve for x and y. So let's subtract 2x on both sides, add 1 on both sides. So we get rid of our 2x. This becomes just x. This goes away, equals 4. And same thing here. If we subtract by 4y on both sides, add 2 on both sides. Now our 2's go away, our 4y goes away. We have 6y minus 4y equals 2y equals 5. Then we need to divide by 2 on both sides to get y by itself. So we have y equals 5 over 2, or in decimal form, that's 2.5. So we got x is 4 and y equals 5 over 2.